In March 1917, Petrograd was a city defined by the chaos of the Russian Revolution. Amidst the political turmoil, a different kind of alarm spread as residents discovered mysterious markings appearing on their apartment doors. Hand-drawn exclamation marks and crosses appeared overnight. Rumors of targeted robberies and foreign spy rings flooded the streets, leading the city commissar to issue a public warning for citizens to erase the signs and detain anyone caught making them. The investigation revealed a harmless source. The marks were apartment numbers, written by Chinese doormen who were unfamiliar with Arabic digits. This chart shows the mechanics of that specific tally system. A cross represented 10, while a vertical stroke represented 1. A sign showing 2 crosses and 5 strokes simply indicated apartment 25. Numbers function as a flexible, adaptable code, a language that humans have hidden, reshaped, and rewritten to suit their immediate needs. 19th century Russian merchants used this flexibility to hide prices from their customers. They scribbled trademarks onto their goods, letter-based codes that allowed them to track cost prices in plain sight. To create these codes, a merchant selected a 10-letter word with no repeating letters. In this example, using the word pravosudie, or justice, each letter represents a digit from 1 through 0 in sequence. Decoding a tag marked VUO requires mapping those letters back to their positions in the word. V is the 4th letter, U is the 7th, and O is the 10th, revealing a price of 4 rubles and 70 kopecks. In environments where privacy is required, arithmetic adopts the characteristics of a written alphabet to gatekeep information. Before these symbols were ever written on paper, mathematical calculation was a physical manipulation of objects. It required hardware rather than mental abstraction. This traditional Russian abacus, or shoti, is a high-speed computing device. Its layout of wooden beads allowed operators to perform complex additions and subtractions faster than early Western mechanical calculators. The legacy of this tactile math remains in our modern financial vocabulary. In the 15th century, money changers worked at specific counting benches, known in German as a bank. Similarly, English merchants used checkered leather cloths as portable abacuses. They unrolled these checkered surfaces to settle accounts, eventually giving us the word check. Modern banking terminology serves as a constant hidden reference to the physical, tactile origins of ancient mathematics. Most of our mathematical education relies on rote memorization of times tables, but that is only one possible procedural habit. The Russian peasant method allows for the multiplication of any 2 numbers without using a multiplication table. We start by placing the 2 factors side by side, 19 and 17. The procedure is a series of halving and doubling. We repeatedly halve the left number, ignoring any fractions, until we reach 1. Simultaneously, we double the number in the right column for every step. To reach the result, we cross out any row where the left-hand number is even. Adding the remaining values on the right, 17, 34, and 272, gives us the total of 323. This exact procedure appears in the Rhind Papyrus, documented by Egyptian scribes nearly 4,000 years ago. They solved complex multiplication problems using this same doubling methodology long before the modern era. Algorithmic thinking is fluid. Different cultures have solved identical logical problems using completely distinct mental pathways. A mathematician's diary contains a seemingly impossible riddle. He graduated college at 44, married a year later at 100, and soon had a family of 10 children. For these numbers to describe a normal human lifespan, we have to look at the structure underlying the digits. The diary was written in base 5, also known as the quinary system, rather than our standard base 10. In a quinary system, the columns represent 1s, 5s, and 25s. This makes the 100-year-old groom exactly 25 years old in our decimal system. Our preference for base 10 is a biological byproduct. We organized our numbers into groups of 10 simply because we have 10 fingers. This biological legacy creates a deep psychological bias toward round numbers ending in 0 or 5. This bias is visible on ancient Roman tombstones. Statistical analysis shows a disproportionate number of recorded ages ending in V or X, as families rounded the ages of the deceased to the nearest 5 or 10. This preference has a modern financial cost. Retailers often round calculated prices up to the nearest 0 or 5, resulting in millions of dollars in markups that go unnoticed because they satisfy our craving for round numbers. Mathematics functions as a flexible, evolving human language that continues to shape our reality, dictate our behaviors, and impact our world today.